This video covers Module 2 Part D, Experimental Research. In this video I'll talk about experimental research, what it is and why it's a really valuable method to employ given that it allows us to infer causal relationships among variables. In AMB 201 we really only deal with experiments at a very foundational level. We do have at QUT the subject AMB 306, Advanced Consumer Research, where we have a lot more emphasis on experimental research design in the consumer context. So I'd recommend anyone that's interested in experiments look at that. It's quite an interesting subject. In today's lecture, I'll talk about some of the basic terminology associated with experiments, and I'll go through a number of the design considerations that we need to take into account when setting up experiments. I'll do that in the context of a number of examples of experimental research that we've done in the past, so that it'll help make some of those ideas a bit more concrete. Towards the end, I'll finish off the lecture by talking about test markets, which are a nice natural application of some of the design principles of experimental research. So what is an experiment? It's a method whereby the researcher will manipulate or change one or more variables in order to see the impact that has on some other variable or some other set of variables. As a nice simple example that I think most of us can appreciate, imagine that you're a researcher and you're interested in those influences on customers in a restaurant that cause them to tip more or cause them to leave a greater amount in tips. You predict or you hypothesize that the tips received at the end of the night will depend on the friendliness of the waiter serving those people. To set that up or test that experimentally, what you would do is take one group of people and expose them to a very friendly waiter. In this case, this waiter's smiling, and you'd look at the amount of tips received. And you'd take another group of people, expose them to a less friendly waiter, and look at the amount of tips received there. You'd make a comparison between these two groups and then hopefully be able to infer whether or not friendliness impacted on tips. That's a very simple layout for an experimental setup, but they actually become quite difficult to set up or quite tricky to set up in order to test that sort of hypothesis. For example, in order to confidently infer that the amount of tips received was solely due to the friendliness of the waiter, we need to be able to say that these two groups are roughly equivalent. We don't want one group of customers to be more generous than the other, or one group to be more hungry than the other, because those things could lead to the differences in tipping. So to achieve that, and the basis of setting up a true experiment is to randomly allocate people or randomly assign participants to one group or another. So in allocating participants across these two conditions, we would want to randomly assign them, make sure there's no systematic influence on which group a participant is assigned to. We'd also want to make sure that there's nothing else about the waiter or the restaurant that's causing tips to change. So we would want to make sure the waiter is roughly the same, two waiters here are roughly the same age, that they're roughly the same level of attractiveness, that they're wearing roughly the same clothing, they're serving approximately the same types of food and so on, because we don't want those things influencing the amount of tips received. When we hold constant or try to make those things constant across the groups, what we say we're doing is controlling those influences. So a couple of points to remember is that we need random assignment of participants to the groups that we want to compare so that those groups are roughly equal, and we need to control as many influences as possible beyond those ones that we're interested in. Those things make an experiment quite tricky to set up, and it can turn a lot of researchers away from an experiment because it does require a lot of attention to detail. But it also makes experiments really quite powerful because once they've been executed in a very rigorous and controlled way, we can be really confident about the causal relationships that we infer. Some of the terminology that we use when dealing with experiments is listed here. Independent and dependent variable are two terms you'll commonly use, and they get abbreviated to IV and DV respectively. Extraneous variables and confounding variables. So let me run through what they actually mean. An independent variable is the variable that you as a researcher will manipulate, or the variable that you will change. So in the case of the waiter and friendliness back here, it's their friendliness. That's your independent variable, the thing that's changing across those two groups. The dependent variable is the variable that you measure, or the thing that you measure. So in the case of our waiter experiment, it's the amount in tips received at the end of the night. Depicting that graphically, what you would say is that the independent variable predicts the dependent variable. That's the overall relationship that we're interested in. Another term to be aware of is extraneous variables. Extraneous variables are any other influence in that environment that might impact on that relationship. So the types of food the waiter's serving, the level of wealth of the customers, whether or not the customers are in a good mood or a bad mood, if the customers are drinking, and so forth. These things will be present in both of those groups, and they can start to distort or contaminate some of that relationship or weaken some of that relationship. And what we want to do is minimize that impact as much as possible so that we get a very clear, clean IV predicting DV relationship. You can remember that term because it begins with the word extra. So extraneous variable is extra variables in the environment. Fourth term to be aware of is confounding variables, or confounds. Confounds are a type of extraneous variable that systematically changes with our independent variable. So if you were to go back to our example back here and you were to say, well, we're interested in the level of friendliness of the waiters impacting on the amount of tips received, and we manipulate that by having a smiling waiter or a frowning waiter. If it turned out that all of our smiling waiters tended to be older and all of our frowning waiters tended to be younger, then what we could say when we see a difference in tips is that it's not due to smiling or frowning, it's due to age of the waiter. Or if all of our customers in our high tipping group were more wealthy and our low tipping group were a little bit less wealthy, then wealth of customers is predicting tips. So a confound is a special type of extraneous variable that systematically changes across groups. The problem with confounds is that they can represent an alternative explanation. So we want to, as much as possible, hold those constant or rule those out when we're setting up an experiment. To illustrate some of these ideas with a study that we ran recently, I want to talk through a field experiment that we conducted on consumer education relating to unit pricing. Within a grocery store context, you might be familiar with unit pricing. This is the price on a shelf label that you might see that represents the amount that you're going to pay per some fixed amount, and that's displayed across all products. So in many products in Australia, we'll see a price per 100 grams or a price per kilo across shelf labels. And this is supplied to customers to help them compare across products that are in differing pack sizes so that we can make a like-for-like comparison. In Australia, this has been mandated in grocery stores since 2009, so it hasn't been around for all of that long, but it's actually been quite well received and it's quite well utilised within Australia. It's been around a lot longer in places like the UK and also the US. In the UK, it was introduced in the mid-1980s, in the US in the early 1970s. And the basis for introducing unit pricing was to help people to save money and specifically help consumers in lower income groups to save money by allowing them to make more informed decisions when they're choosing between grocery products. So it's been around for quite a while in those places, lesser time in Australia, and what we were interested in this study was how well consumers use unit pricing, whether or not they use it to save money, and if educating consumers about how to use unit pricing would impact on the amount that they save. Because if you look in the literature, one thing that you find is that while unit pricing is often readily displayed, a large proportion of consumers simply don't use it. And what often crops up in many studies is that low-income consumers, those consumers that it was initially introduced for, and those who could potentially benefit most by using it, they are the groups that use it least. So this is a bit concerning. So we ran a study a couple of years ago looking at, well, if we educate people about unit pricing and if we educate low-income consumers about using unit pricing, then do they actually go on to save money? In Australia, unit pricing is displayed a lot like on the label in this example here. It's displayed fairly consistently across stores. It's quite standardized. In other countries around the world, there isn't quite as much rigor with the way it's displayed. In the US, it's mandated in some states and not others, and it differs in the way it's displayed across stores and also within stores. So in this image here on the left, you can see a variety of ways in which unit pricing is displayed, where up here we've got it in a different font, in a different colored background off to the left. In this one here, it's to 4 decimal places in a small font off to the left. Over here, it's under the selling price. Here, I'm not sure where it is, or it's under the selling price in a very small font. Here, it's displayed differently again, and so forth. So in the US in particular, people often find it a bit confusing. They don't know where to look for it, and stores are often widely criticized for not displaying it appropriately or displaying it in a way that makes it difficult for consumers to use. Within places like Canada, it's not mandated very widely. Quebec is the only province where it's mandated. And one thing that I've noticed in Canada is that it's often displayed in a way that doesn't make it appear as a price. So again, it's not very helpful for consumers if they're not really aware of why it's there or what it represents. Here you can see in this instance it's displayed to 4 decimal places, which doesn't make it appear as a price at all. So if people are not familiar with unit pricing, they can be a little bit confused about what that information is telling them. Down here, another common criticism, particularly in US stores, less so in Australia, but it does crop up occasionally, is that the metric being used is entirely different. So I believe these prices came from tissues, and here you can see that this is a price per 100 count in tissues, and this is a price per pack. So unit price is displayed, but it's really not in a common metric, so it becomes unhelpful for consumers. So what we were interested in doing in our study is educating people about unit pricing and seeing whether or not that would lead to greater usage. So for our research, we chose to use an experimental design to examine consumer education around unit pricing. Certainly there are other methods available to us, and we've talked about a number of those methods in AMB 201. Hopefully you can start to think about why they may or may not be appropriate for this type of setting. You could think about something like qualitative interviews, where we bring someone in and we interview them about their usage of unit pricing, or ask them how they might be influenced by educational material about unit pricing. Two things that should instantly jump to mind there are that people may not necessarily have insight into their past usage of unit pricing. So you can imagine yourself when you go into a store and you make a purchase, sometimes you perhaps look at unit prices, sometimes you don't. We're not always aware of when we're doing it. We don't always recollect when we've looked at it or how we've gone about using that. And if we were to ask people about whether or not they think they would be impacted by consumer education, probably we'd get socially desirable responses, with people saying, well, I already use it, or yes, of course, giving me educational material is a good thing and I'd use it more. So qualitative interviews might not give us that insight that we want, and certainly wouldn't allow us to infer causal relationships. We could look at something like observational research, where we might stand within a grocery store and try to see whether or not people are using unit pricing. That might not always be very accurate because we can't tell what people are looking at, or we might follow someone around a store using an undisguised approach. The difficulty with that, though, is that you standing beside someone watching what they're doing can impact on what they actually look at when they're making a product comparison, for example. We could use eye tracking technology, but again, the very fact that someone is wearing an eye tracker may make them a little bit more thorough or a bit more rigorous when they're making their grocery comparisons. We could certainly use a survey and ask people whether or not they use unit pricing, removing that experimenter or researcher influence. But again, we'd likely get socially desirable responses. We'd also get issues around what we term self-selection bias, where a certain type of people may be more inclined to take part in that sort of study. People who know that you're running a study about unit pricing, taking part because they like the idea of saving money, or they're interested in grocery shopping or something like that. So survey research not always ideal. We also, again, would get socially desirable responses with people indicating they use unit pricing when perhaps they don't, because they're aware that it's a positive thing to do, and really if it's there, they probably should be using it. So people indicating greater usage than is actually the case. Certainly there has been research that has used these other methods, but for our study we were looking at causal relationships. So we wanted to avoid some of those issues and look at causal relationships, so therefore we chose an experiment. We can look at the data that has come out of self-report studies in the past around awareness and usage. In Australia, these figures are really quite high. We've got around 95% of people that typically claim to be aware of what unit pricing is, or they're able to describe what it is, and 80% of people claim to use it in a consistent manner. So these are really quite high figures. If you compare those to the sorts of figures you see in countries like the US and the UK, they're really quite high. In those other areas, it can be as low as 1/3 of people actually report using unit pricing. One issue that we can identify with these Australian figures, though, is that social desirability may play into that. So I've got a study here that I'll place up in the learning resources that was conducted by Svetlana Bogomolova at the University of South Australia a few years ago. And she placed people into a simulation environment where they took part in a grocery shopping task where unit prices were displayed for some products and not for others. And what she showed was the impact that has on people's purchase decisions. An interesting finding that she found in that study, though, was down here, where she reported or found that approximately half, so 45% of participants who didn't get shown unit pricing in their study reported that they used it or reported that they saw it. So very much, if we say that 80% of people report using unit pricing, and Svetlana's study was showing that approximately half of those people in her study said that they used it when they couldn't have because it wasn't present, then we've got a bit of a social desirability issue there, or a self-report issue there. Studies in the UK have shown that 1/3 claim to use it, 1/3 say that they don't bother to use it because they don't see value in it, and 1/3 of people say that it's too difficult to use. Now, this is really concerning to me because unit pricing should make comparisons easier. If we're hearing that 1/3 of people are saying that it's difficult to use, then that's a little bit of a concern, because perhaps they don't know how it should be used, which speaks to the need for why we might require a bit more consumer education. So within an experiment, to set this up, what you need to do, and thinking back to that example I gave before, is get two roughly equal groups of people. So they're going to receive differing levels of consumer education. So we want two roughly equal groups of people. We would want to randomly assign people to each of those groups. And then what we would do is expose some to education about unit pricing and some to no education about unit pricing. Those people may get no information, or they might get, say, nutritional information or something else, as long as it's not unit price education. And then what you want to do is compare their spending, or compare whether or not they're saving money based on usage of unit pricing, whether or not they're using unit pricing in some capacity. There could still be differences across these two groups, but because we've randomly assigned people, we would hope that they're roughly similar. An alternative to randomization that is sometimes used in this type of design to ensure that those groups are roughly equivalent is what we call matching. Matching is where we would look at, say, the household sizes, and we would try to match on household sizes. So you can see each of the groups here have a 3-person household, each of them have a 1-person household, each of them have a 4-person household, a household with pets, and so on. So the groups are made equivalent by the researcher. Matching is an alternative to randomization, but when you match, you have to be very aware and careful in the variable that you choose to match on. Here we would be matching on household size. You could match on something different, such as household income or geographic location or something like that. So in our study, we needed to think about things like family size, household income, time of testing, because obviously people's purchases differ at depending on the time of year, if it's close to Christmas or at some other time of year where people might buy different things, these could come into play. So what we did was set up a longitudinal study. In our study, we chose to use a 20-week period. So remembering back to our survey lecture where we said a longitudinal study is where we take measures at multiple points in time, we can do that with an experimental design, and that's what we did in this study. We recruited initially around 450 people to take part, and we did this through newspaper advertisements. And we asked them to send in their grocery receipts each week. We took about 5 weeks of grocery receipts to get a baseline measure of their general average spending, and then what we did was give some of those consumers consumer education about unit pricing and others no consumer education about unit pricing, and we monitored their spending across a 20-week period. We did actually have 3 groups. So one group is what we call our control group, who got no education. We got a low intensity education group. So these people got information about unit pricing every second week, because our thinking there was that if we educate them quite gradually or quite slowly, that we'd have long-lasting effects. And then people who got a high intensity of education, so weekly letters about using unit pricing and reminders of what unit pricing was. We found that the average amount spent on a grocery product across our sample was about $3.60. I think it was about $3.59 to be a bit more precise. For our control group across the 20-week period, we found that spending didn't tend to change too much. So these are the people who didn't get information about unit pricing. They had no reason to change their spending, and we can see that their spending tended to fluctuate around that baseline level. For those people who got high intensity education, what we saw was that they started to save money fairly considerably. For the first 6 weeks of their study, their spending dropped by about 20%. So they're actually saving around 20% of their grocery bill, which is quite substantial. Once the consumer education stopped, though, their spending started to drift back towards baseline. We also saw that same exact pattern with the low intensity consumer education group. So from this, what we were able to conclude was that if we educate people about unit pricing, even in a market like Australia, where most people claim to be aware of it, that they actually start to save considerable amounts. Once that education stops, their spending will drift back to baseline. So what we suggested out of this research was that retailers or perhaps consumer advocacy groups might want periodic education campaigns or reminder campaigns telling people to use it. And this has been actually quite powerful research, because the international standard that's being created for unit pricing at the moment has taken on this research, and that's been incorporated into that standard. So that's really quite a nice outcome for that piece of research. When it was introduced into Australia in 2009, the ACCC used this type of consumer education material, and you can see that that's pretty much elaborates on what unit pricing is and how it can be used. Some people were a little bit negative about that educational campaign. They found the little calculator man a little bit too patronizing, but certainly what we suggest in our research is that this can be helpful, and especially if it's done periodically. So in thinking about the independent and dependent variables in that study, the independent variable was clearly level of education. We were looking at whether people got no education, a high intensity education, or a low intensity education. And our dependent variable, the thing that we were measuring, was the amount that they spent, or the amount that they spent on grocery products. So that's the IV-DV relationship that we were looking at. Design issues that you always need to take into account when setting up experiments then. Randomization, we've mentioned that a few times. We want to ensure people are randomly allocated to groups, and that's what we do in what we term a true experiment. Or alternatively, we can use matching to make the groups, or force the groups to be somewhat equivalent. We need to employ some sort of comparison condition or a comparison group, which we call a control group, that we can compare treatments against. And then we have this issue that's very important in experimental research, which is about blindness. So having a blind study or a double-blind study. When we talk about a blind study, what we're saying is that participants don't know which condition they're in. We don't want participants to display what we term demand effects and start acting in a way that they think the researcher wants to see. So very often we won't tell them what condition they're in as part of that experiment. We say they're blind to that study or blind to that condition. The next step up from that then is what we call a double-blind experiment. And this is where the person executing the experiment also doesn't know which condition the person is in. So think about a taste test, for example, with this image down here, where the research participant doesn't know what drink they're testing or what they're tasting. But if the researcher is also blind or unaware of which condition is which, then we say that that's a double-blind study. Obviously, there's someone that has to be overseeing the whole study who's aware of what the participant is seeing or what condition the participant is in, but the person actually executing it, if they're blind to it, that can also be valuable. That can avoid the researcher inadvertently biasing findings by perhaps looking a certain way when the participant drinks a certain drink. So it's quite a useful technique to employ. I want to run through an alternative example very briefly to help illustrate a couple of additional design considerations, but also to cater to anyone who's not necessarily interested in unit pricing. So imagine that you're a researcher who's interested in the effects of games on kids, or more specifically the effect of advergaming on kids. So remember that an advergame is a game developed by a brand that often includes branded content or advertising content as a way of reaching younger consumers. So you can see an example on your screen of an advergame developed by McDonald's as a way of reaching younger consumers. If you were interested in the effects of that as a researcher, you might examine that experimentally by taking a randomly selected group of kids, exposing them to an advergame, so perhaps getting them to play that game for 60 minutes or longer, and then measuring something in them as an outcome variable, or measuring a dependent variable. Here it might be whether or not they make requests for McDonald's or whether or not they eat McDonald's. You'd want to compare the rating in those children to a rating in what we would term a control group, or a group of kids who don't get exposure to the advergame. And you'd want to see differences there if you thought that it was actually having an effect. One critique of this type of design, though, is that our control group isn't getting exposed to anything. So it's possible that the difference in consumption of McDonald's or rating of McDonald's is actually due to the fact that the kids in the treatment group are getting exposed to a game. So perhaps they're just more generally excited or more energized by having played the game. So what a lot of researchers will do in their control group is not give an absence of anything, but they will provide an alternative comparable condition that in this case doesn't include the branded content. So our control group in this instance would receive a game that doesn't include that branded content, and that's seen as a little bit more comparable. This represents a nice illustration of what we would term a true experiment, in that it contains a control group, but it also has randomization or random allocation of participants across those two groups. An alternative to a true experiment is a quasi-experiment, where you have two groups that you're comparing, but they're not necessarily randomly assigned participants. So sometimes you have to take naturally occurring groups in order to make a comparison. You can imagine that would be the case if you wanted to compare smokers with non-smokers. You can't necessarily allocate people to a smoker group or a non-smoker group in an ethical way, so we often have to take pre-existing groups. The downside of that is that those groups may have some pre-existing difference already that leads to the change in an outcome measure that's not due to what you think it is. So there can be other differences between those groups beyond the ones you're interested in. So why would a researcher do that? Sometimes we have to do that. In the case of something like gender, we can't randomly assign people to a gender. So if we wanted to examine the effects of advergaming in boys versus girls, obviously we'd have to run a quasi-experiment as opposed to a true experiment. Another couple of things to think about, we've got within subjects designs versus between subjects designs. A between subjects design is where you have different groups of people allocated to each of two or more groups. You're comparing one group with an alternative group. A within subjects design differs to that in that you only have one group, and the one group is getting exposure to all of the conditions. This gets around the problem of groups potentially differing in some way, but has the downside of perhaps exposure to one condition influences the responses people give to a second condition. Another thing to be aware of is that some studies can be run in the lab, and we call those controlled lab studies, or they might be run out in the field, and there are pros and cons that differ with each of those. You can imagine in a lab study, so we bring someone into a laboratory environment or a computer lab, for example. The benefit of that is that we have a very controlled environment. We know there aren't any other extraneous variables, or we're minimizing those extraneous variables that might influence people's responses. So we tend to get a much cleaner IV-DV relationship. We can be much more confident that changes in our DV are due to changes in our IV, for example. The criticism of a lab study, though, that we often get is that while the effect is found in the lab, how do we know that that effect will play out in real life or out in the field? A field study can be run to address that, so we can run a study out in the field in real life. The difficulty with that, though, is that there are lots of extraneous variables or extraneous influences on our participants that can distort or contaminate our findings. So in general, we say that experiments are a very powerful technique. They're a technique that allows us to infer a causal relationship between variables. If you think about the three designs available to us that we went over in Module 1, exploratory research, descriptive research, and causal research, causal research is much more controlled. Experiments are a much more controlled form of methodology, but they're the only ones that allow us to get at those causal relationships, and that's where the value of them comes from. And finally, I want to talk briefly about test markets, which are a natural application of experimental design principles in practice that marketers can use. So we've been over this in an earlier lecture, but this is where essentially a marketer will introduce some sort of change to their marketing campaign or their promotional activities or to their distribution within a limited section of their market in order to see whether or not that's having some impact. Three types of test markets to be aware of: standard test marketing, control test marketing, and virtual reality test marketing. Standard test marketing is just the type that I've previously described. So where the brand might restrict distribution or restrict some promotional campaign to some subset of their market or some limited geographical area or some limited group of stores, and look at change that occurs just within that area or just within those stores. The control method of test marketing is a little bit more forced. This is where the brand doesn't just provide retailers with their products and ask them to sell them. What they do is purchase up shelf space specifically for displaying their test marketed products. And this is really valuable because sometimes a retailer, when they get a test market product, might put it on a low shelf or might put it out in an out of the way space. The brand doesn't have a lot of control over that, and what they want to ensure is that it is actually in front of consumers so that they can see whether or not it's going to sell. So this control method of test marketing is a little bit more deliberate on the part of the brand. We often see this take place in shelf spacing at the end of aisles, and we call these on end caps. So often if you look at products there's a chance that it may be a test marketed product. Virtual reality test marketing or simulation test marketing may be a big direction in the future where this could go. Simulations have certainly been around for a long time, so looking at a computer screen and having a participant go through a simulated environment to see what they purchase. But virtual reality test marketing probably hasn't taken off to the extent that it could, but there is a potential for it to do that in the future. Having people wear VR headsets or virtual reality headsets and navigate around a VR store and see whether or not they purchase the products that you put in front of them. Test marketing in that sense. You can see why using some of those experimental design principles would be very doable in that type of environment. You can control the level of exposure people get to certain products, how many other people are in the store, the position of those products, and so forth. So that virtual reality approach may take off in the future. It's certainly an interesting space to watch, and it'll be interesting to see where that goes. That covers everything that we need to talk about with experiments. We've been over terminology and gone over a range of design considerations. Hopefully the illustrations have helped to make those clear. And we've also talked briefly about test markets and how they represent a natural implementation of some of these principles. For the next video, we'll be moving into Module 3 and we'll be talking about survey design and some of the design considerations that we need to make.